But the situation is not hopeless, and as an example of building a better protocol for a specific application, we'll look a little bit at the QUIC protocol. QUIC originally stood for Quick UDP Internet Connections, and you see right away how they're getting past the ossification problem by still building on existing protocols, in this case the UDP protocol instead of TCP. This protocol was first implemented in Chrome around 2012, and through gradual process, it became standardized in 2021 as RFC 9000, and it's implemented in most major browsers. To make a new protocol for the web, you need both servers and the browsers to agree on the possibility of using it, and that's pretty much in place now. So again, QUIC builds on UDP. That's how it works over the existing internet. But unlike UDP, it's connection-oriented, so it builds a layer on top of UDP for implementing and managing connections. And these connections are going to do a lot of the TCP kinds of things, but the connection is going to be based on a connection ID that's separate from the host and port. And so that's how QUIC can solve the parking lot problem, by separating the connection idea from the IP address idea. QUIC is also going to have built-in encryption, and that means we don't need extra layers of handshakes. We can reduce handshake hell by collapsing many of the handshakes. And it also has a different strategy for dealing with dropped packets so that it can interleave different connections without the head of line problem that comes with dropped packets. The overall picture for QUIC is that a client sends a connection request to a server. In that very initial connection request, which is just a UDP packet, the client picks a connection ID. So it's going to pick a random number here, likely to be different from all connection numbers. But we don't rely on that randomness for security, because in that very first message, we'll also start a TLS handshake. So this is both setting up the connection independent of the IP address of the client, and also reducing those handshakes, collapsing them into one right from the start. The server can then respond to finish setting up that connection, and so we're moving things along with a special connection ID. And if the client then moves into the parking lot, off the Wi-Fi onto the mobile network, it can continue talking with that same connection ID. And not only that, it does not have to renegotiate the encryption here. The same TLS setup that we used before can continue being used because both the client and the server know about that connection ID. The last piece of the puzzle is that in QUIC, there's not just one stream of packets within that conceptual connection. Instead, different streams can be created within the connection, all using the same encryption agreement, so that doesn't have to be renegotiated. But because QUIC is getting these UDP packets and can directly itself deal with dropped packets, it can isolate individual streams. So if HTML page gets delayed by drop packets, we can still keep fetching, say, images at the same time. QUIC has to do all the other things that TCP does in terms of flow control and congestion control. It takes the same ideas and just repackages them with this refined notion of streams within a connection implemented on top of UDP.